Just a minute. That is, in our last class, we already discussed some of the fundamental operator or operations in relational algebra, and these basic or fundamental operations are select, project, union, and set difference discussed in our last class. Now we want to discuss the next operation, that is the Cartesian product and rename operation. Okay, do you have any question in our previous class?
Minimum.
Yes or no?
No, sir.
Please pardon me. Okay. Next operation is the Cartesian product. The Cartesian product is represented by a cross symbol. Okay. Uh, this operate on the more than one relation. That is, in this case, it operate on the relation R and S. Okay. So we can define R cross S. That is the Cartesian product of S. This results the tuple T from relation R and tuple Q from relation S. That is, it result the T follows Q. That is T and Q in together. Okay. The where T actually comes from relation R and Q comes from relation S. Is it okay? And here we assume that the attributes of relation R on the relation schema capital R and another relation S are disjoint. That is, in both the relation R and S, R relation and S relation, both the relations are actually disjoint. In that sense, there is no common attribute is there. And if there is any common attribute is there, that is, if it is not the disjoint, then the renaming must be used. Okay. Now we want to solve example. It will be more clear what task actually performed by the Cartesian product. Suppose this is the relation R and these are the content. How many attributes are there? Two attributes. Attribute name is the A, attribute second attribute is the name is B. And S contain the three attributes C, D, and E. And these are the content of relation R, alpha 1, beta 2, and so on. Now, if we perform the Cartesian product of R cross S, then what are the attribute for that? What are the attribute for that, please? Please tell me, anyone from you? What are the
Sir,
attribute?
ACADAE.
R cross S means basically tuple T from relation R and Q from relation S. That is where T belongs to R and S belongs to sorry. Q belongs to S. Okay. So what are the attribute? A. Please pardon me. What are the attribute? The tuple comes from relation R. So in relation R, what are the attributes are there? A and B. So A and B is present in result, as well as the tuple Q. Tuple Q actually comes from where? From relation S. In tuple Q, each tuple, what are the attribute? C, D, and E. So for C, for D, and for E. Okay. Is it clear? Now comes to the point, that is, this one is the this A, B, C, D, E. These two are from relation R, and this from relation S. Okay. Now what are the content of this? What actually says here? The tuple taking from S relation and as well as the from followed by Q relation. So first actually we can take the this tuple. What is alpha 1? Okay. So alpha 1 is the T. If alpha 1 is the, this is the T, if this is T, then which one Q? For this is one of the Q, this is another Q, this is another Q, this is another Q. So for that, alpha 1, alpha 10 A. Okay. Now consider this one, that is alpha, beta, one thing, beta 10 A. That is, you try to understand T and Q. T and Q. T comes from relation R and Q comes from each of the tuple from relation S. So for one tuple T in relation R, that is alpha 1, the alpha 1 is merged with each of the tuple in S, that is alpha 1. Here this one, what is this? Beta 20 B. Next one, gamma 10 B and alpha 1. Is it clear? That is, for the first tuple, it merged with the each of the tuple in relation S. Okay. So this part is the T, this part is the T, and this part actually is the Q. Okay. That is, if this is a T, this is a Q. Is that clear? So for the first tuple, one tuple of the relation R is combined with the each of the tuples in S. So now consider the second tuple. So what is the second tuple? Second tuple is the beta 2, and for beta 2, it again combined with the each of the tuples in relation S. So this is again alpha 10 A, beta 10 A, that is beta 2, then beta 2, beta 20 B, and gamma 10 B, that is the last column, and this is beta 2. Is it clear? That is main thing. The tuple, this one, comes from relation R, and each of the tuple comes from relation S, and we got this one. Now when we consider this part, that is beta 2, for that this part is added. Is there any question, or is it clear, or any confusion need to be discussed again? The Cartesian product is the one of the important operation in relational algebra. Is it okay, or need to be considered? Need to be considered. We can consider discuss again.
Sir, could you explain again, sir?
Explain. Please pardon me.
Sir, could you explain again, sir?
Sure. Okay. Just a minute. can see what is the this actually definition. R cross A or R Cartesian product S is the T tuple from relation R and tuple from relation S. Okay, that is T followed Q, that is T actually preceded by Q, or we can say the combination of T and Q, where T is belongs to R and Q belongs to S. So, so here R cross S means the what are the attributes? The attributes of these two and attributes of these three. That is the attributes are in this Cartesian product. What are the resultant attributes? Combination of both the relation, that is A B from relation R and C D E from relation S. Okay. Now question is regarding the content. So in content, it consider the first row of this and combine each of the row of the relation S. That is, if this is a T, then each of these is a Q. This is a Q again. This is a next Q. This is a Q. Okay. Is it okay now? So when we consider this row from relation R, if it is a T, then this part is a Q. So A, B, C, D, E. These are the different attributes of the resultant relation or R cross S. So here alpha and 1. This is the T. Okay. And what is the Q here? This one. Alpha 10A. Okay. And for the same T, alpha 1, this will be the Q again. The next one is the Q again. That is beta 10A. Similarly, beta 20B, alpha 1. That is, this one is the T basically. This part is the T, and this part is the Q. This part of the Q. Okay. And here gamma 10B. Okay. So what is this? You can see the first row of the relation R is combined with each of the row of the relation S. So you can think just like this one. The first row, this is the T, is combined with each of the row in the relation S. That is this portion actually comes and together we get this one. Up to that, is any question or is it okay? Is it okay? Yes or no? That is first row combined with each of the row of the S. Now consider the second row. Consider the second row. Again, second row combined with each of the row. That is, what is the second row of the relation R? Beta 2. And combined with each of the row. That is, the first row is the Q here. That is alpha 10A. Then consider this is the Q as a Q. So beta 2, this is a T. This is T basically. Beta 10A and so on for the rest of the tuple. That is, for this tuple in relation R, consider each of the tuple from relation S. So what are the remaining portion here? What are the remaining portion? If we combine this, we get this one. That is, you can see the beta 2, that is beta 2, and this combined with first row, first tuple of the S. That is, this is the first tuple of the S. That is, this portion is the Q now, and this portion is the T. Okay. Now, when beta 2 is the again T, tuple T, then consider the second tuple in the relation S. This is the second tuple in relation S. Similarly, combined with the third tuples, both tuples, and finally we get the result of the Cartesian product. And this is of course one of the relation. I already told the relational algebra operations are operate on the relation, one or more relation, and result is also a relation. Okay. Is there any question? Is there any question? Yes or no? Now,
No, sir.
now we want to build a multiple using the multiple operation. Till actually we discuss the single operation, that is the select operation, project operation, I mean union operation, set difference operation, and Cartesian product operation. So multiple operation is also possible and of course needed. So the same example, the relation, this is the relation R. The just previous example, this is the S. So what is the R process? R process is the this one. Is it? Na? R process is this one. So if we perform the operation, say this one, that is R cross S. For R process, what is the result? This is also a relation. Is it? Na? This is the result. R cross S. This is a relation. So this select operation, what is this sigma? Sigma is a select operation. What actually tells us sigma? What actually tells what task actually performed by the select operation in relational algebra? Please tell me, anyone from you.
So
Select operation, it select the row or tuple from the relation where the condition is satisfied, for which the condition is satisfied. Is it? Na? For which the predicate is satisfied. Is it or not? Is it? Na? Sigma T R. General form is the this one. What is the result? It results a tuple T such that tuple T present in R and not only present, and condition P for this tuple is true. That is this one, this condition is true. Okay. Then that tuple is considered as the outcomes. So in that case, what is the condition? Here predicate is the, what is the predicate? Condition here A equals C. Now we can see the attribute A and attribute C, where both are equal. Here it is equal. Is it that? It is equal though. Yes or no? Here A and C are equal. That is condition is met. So this row is considered as the outcomes. Before that, actually, please tell me what are the output relation? What are the attribute? What are the attributes of the output relation?
So same as R process.
Same as R cross S. Okay. So what is this? A, B, C, D, E. Now question is, from A, B, C, D, E, which one actually consider? The first row is considered, because here A, the tuple A value is the what value of A? A is alpha and C is also alpha. So condition is satisfied. So we can consider this is one of the row of the resultant. Now check, this one is equal? No. This one is equal? No. A is not equals C. Alpha not equals gamma. Now check the beta not equals alpha. So this row does not consider as the outcomes. Now check that this beta and this beta are equal. A and equals C. This condition is satisfied. That is, this condition is satisfied. So if this condition is satisfied, that means this tuple consider as a output. So what is the tuple? Beta 2, beta 10A. Beta 2, beta 10A. That is, this is considered as a outcomes. Okay. Now again, you can check here the beta equals beta. That is, A equals C is satisfied. So this one also, this tuple also considered as a outcomes. That is this one. Beta 2, beta 20B. Okay. And here you can see the beta is not equals to gamma. So A equals to C, condition is failed. So that other tuples are not considered. So only these three tuples satisfy the predicate. What is the predicate here? Here predicate is the A equals C. Here predicate equals A equals C, or condition or predicate. Predicate P is, in this case, A equals C. So when A equals C is satisfied, that tuple considered as the outcomes. Is there any confusion? Yes or no?
No, sir.
Now, rename operation. This rename operation allows us to name the result of relational algebra expression and also allow us to refer to the relation by more than one name. And what is the general form? The rename operation is by the row symbol, row xe. What is the meaning of that? It returns the expression, relational algebra expression or relation e under the name of x. Okay, so the relation e or relational algebra expression e is another name. What is this? X. Okay, so if the relational algebra expression e has the n, arity is n, arity is n means what? What is this? Number of I already told in my previous class. Arity means number of attributes. That is, in relational algebra expression e has arity n, that is the number of attributes n. Then if we write row x inside the bracket a1 a2 up to an e, then what is the meaning of that? This expression is named by x, and in x how many attributes are there? N number of attributes are there, and that attributes also renamed with a1 a2 a3 up to an. That is, attributes are also renamed. Is it clear? There may be chance the e in case of e, the attributes are say b1 b2 bn. So if we write this, then b1 actually changed to name a1, b2 is also known by name a2, this is also known by name an. Is it clear? And if you have not write any attribute inside the bracket, just like this one, then the same attribute name of e is considered as a attribute name of x. Is it clear or any confusion? That is row
Sir, could you explain
operator
again, sir?
use. Again, row operator is used for the renaming purpose. E is the relational algebra expression, maybe any relation also. Suppose if we write the say a, you know the account is the one of the relation, is it na? Account is the one of the relation. What is there in account? Account, what is there? Account number, balance and branch name, is it na? So this account, this is a relation, or maybe it is a relational algebra expression. It is a single relation. For that it will be easy. Maybe if we write the account cross just previous one, r cross s, that is a relational algebra expression, is it na? There may be right if we write the say y r cross s. What is this? The result of this is renamed with y. Okay. So here similarly, account is renamed or another by another name. What is the name? A. If you have not mentioned any attribute name inside bracket here, at that time the attribute name of the account is same as for the new name A also. But if we mention here, say here A1, A2, A3. Three attributes are there, na? How many attributes in account relation? Just a minute. Account number, branch name and balance. That is, if we write this one, what is the meaning of that? Meaning is, in account relation, the attributes are account relation attributes are, just I want to see this, just wait. Account number, account number, branch name, and another one is the balance. Okay, so if we write the attribute name here at the time of renaming, so this account number is renamed or by another, known by another name A1 attribute, this is by A2 attribute, and this is by A3 attribute. Okay, if you have mentioned the attribute name here, if you have not mentioned, then the same attribute name of the account is considered in case of A also. What is the A? A is basically an account relation. That is, account relation has the two name, account name, another is the A, name is the A. And if we want to rename the, attribute name, then it is mentioned inside the bracket after the new name. Is it okay? Yes or no? So that means this X is the new name and E is the expression. For example, account is the expression and A is the new name. What is the new name of the account? A. Okay. Now, the 6 fundamental operations already discussed. Now we formally define the relational algebra. The formal definition: the basic expression of relational algebra consists of the following: either a relation in the database or a constant relation. That is, constant relation means outcomes or result of, say, R process. And suppose E1 and E2 is the two relational algebra expression. Okay. Then the following are also two. What is this? E1 union of E2 is a relational algebra expression. Set difference is also a relational algebra expression. Cartesian product between the two relational algebra expression is also a relational algebra expression. Select operation is also a relational algebra expression. That is, the P is the predicate on the attribute E1. And this is the project operation. The project operation here, S is the list consisting the sum of the attributes of E1. That is, the desired means what attribute we want to display. That is the S, the list of attributes. That is the list of attributes we want as a outcomes or result. And this list of attributes belongs to E1. Not all the attributes of E1 actually we want. We want some of the attributes of E1 as a outcomes or as a output. So this is the project operation. And last one is the whatever renaming operation. Here, this is perform the renaming of E1 to the new name X. That is, X is the new name for the result of E1. Okay. So this is the formal definition of relational algebra.
Sir, what is the second last one, sir?
Second last one. This one is the project operation. This one I think I already discussed in last class. Project operation means basically it can take the select operation. What actually performed by the select operation? Select operation take the tuple. Tuple means row of the expression or relation E1, where condition P is satisfied. Okay. If P is true, then that tuple, whole tuple actually considered as the outcomes. But here actually, whole tuple means all the attribute values are there. Is it not? In this case, the result contain all the attribute values because the whole tuple or whole rows considered if the P is satisfied. But here, we don't want all the attribute. Okay, we want, say, some of the attributes of that relation. Suppose if we write the account is the relation. What are the attributes? I already told. Account number, branch name, and third one is the balance. Is it na? Suppose among the three attributes, if we want all the three attributes value, that means each of the tuple, then we can use the select operation. But if we want only the say account number, we want only the account number. So at that time we write here account number. Okay. So this project operation operate on the relation account. It gives only the values taken from the account number. It does not consider the value, balance and branch name from the account relation. Is it clear? If we write say this one, say account number, comma, balance, relation is the account. So what is the outcomes for that? Outcomes actually the account number and corresponding balance. Not display the branch name, because account relation consists of three attributes: account number, branch name and balance. By this operation only display the account number and balance. By this display only the account number from the account relation. Is it clear? Is it okay na?
Yes, sir.
So that means the S, this S is the, in this case only one attribute account number, in this case account number and balance. That is some of the attributes. Okay. But if we write only say sigma account, say no condition, then what is the outcomes? All the content of the account, that is it shows the values of the column account number, values of the column of the branch name, values of the column of the balance. Okay. If there is a no condition is there, if any condition is there, say balance is greater than 10,000, then it can display the account number, branch name and whose balance is greater than 10,000 rupees, and less than 10,000 is not displayed as a result or not considered as a output relation. So I think it's clear. Now suppose we consider example. For the example, the banking database system we consider. Here, what are the relations we already told? The branch consists of branch name, branch city, asset. Here branch name is the primary key. Customer name is the primary key, customer street and customer city is there. And of course for simplicity purpose we assume here the no two customer have the same name. That is the, for simplicity purpose we assume here the customer names are unique. Okay. Next one is the account. Here account number is the primary key and branch name and balance are the other two attributes. Okay. Loan number is the attribute, loan relation and branch name amount. That is the, in loan actually how many total attributes? Three attributes: loan number, branch name and amount. Which one is the primary key? Loan number is the primary key. Similarly in the depositor, customer name and account number. These are the two attributes, and these two are the combination of these two is the primary key in that case. Okay. So and borrower relation, similarly combination of these two, that is borrower is it not? These relations are actually derived from the entity relationship diagram. Do you remember this one na? Entity relationship diagram, it can derive from the ER diagram. That is ER diagram help us to find out the, from here you can see here for depositor is the one of the relation. So when we this relationship set convert in a table or convert in a relation, then what are the attribute? When we discuss about the ER diagram chapter, what is the attribute of this relation correspond to the relationship set depositor, primary key of the connected entity set. What is the primary key of account number, and what is the primary key of the customer name. So you can see there in the account relation, account number, oh sorry, depositor relation, sorry, by the depositor, this one. In the depositor relation, corresponding to the depositor relationship set, attributes are customer name and account number. Customer name is the primary key of the customer entity set, and account number is the primary key of the which entity set? Account entity set. Is it? So for depositor relationship, for borrower relationship, there is a one of the relation. For account relationship, one of the relation. Customer relationship, one of the relation. This one is the other relation. This one is the other relation. But for loan branch and for account branch, no new relation actually created to remove the redundancy. Instead of, for this relationship set, instead of new relation, the primary key of the one of them, that is the branch name is the primary key. This branch name is added to the account table or account relationship. So for that, in entity, when we draw ER diagram, in account entity set, here account number and balance is there. But when we convert this one in a relationship, in our relational algebra or SQL, when we talk about the relational data model, their account relation consists account number, balance, and as well as branch name, the primary key of the other entity set, because we don't take this relationship as a one of the new relation or table. Similarly, in case of branch, that consider the account number is the another. Just a minute. Sorry. So these are the corresponding tables. Okay. And now, because these relational tables are required when we find out the or answer the query. Suppose for simple query, find all loans over, that is the loan amount is greater than 10,000. So how we get this information, or how we write this query in relational algebra? Please, anyone, which table or which relation need to be consulted for this case? To answer this query, that is the find out the all the loans over rupees 10,000. Which relation need to be consulted?
So loan
Which
table.
relation? Loan table or loan relation? That is the loan relation. That is, loan relation consists of loan number, branch name, and amount. Because we find all the loans over 10,000 rupees. So for that, which operation need to be performed? Which operation need to be performed? We can perform the select operation. Select. What is the condition here? Condition is this
Amount greater than.
Amount greater than 10,000. Okay, and relation name is loan. Okay, that is, this is the desired query. Okay, is it clear now? So this actually provide us the, what is the outcomes? Outcomes of the tuple, that is the row. That is, outcomes consist a relation, that is, each of the row consists a loan number, branch name, and amount. But which row or which tuples actually consider as a result? Where amount is greater than 10,000 rupees. Is it clear? Not all the rows or all the tuples of loan relation is not displayed as the outcomes here. Only the tuples of loan relation consider which tuples? Those tuples the loan amount is greater than 10,000 rupees, because this is our query or question. Okay. So if suppose we want the information the loan amount is greater than 10,000, and as well as the NIT Durgapur branch, that is we want all the loans in NIT Durgapur branch loan amount is over 10,000 rupees. So here we can add one of the which condition, and condition, branch name. What we write? Branch name equals, name equals NITD. Okay, that means when both as the outcomes. Is it clear? That is this one. This one actually what actually finds? That is find all loans at NITD branch of over 10,000. Okay. Now suppose the next query is, problem. Just a minute. Okay. So next query is, what is the next query? Find the loan number for each loan of an amount greater than 10,000 rupees. That is what we want to find. So how do we do this?
So project operation.
Please.
So project
Please pardon
operation on the project operation on above query.
Project operation
On such sigma query.
Sigma query. Okay. That is this portion. That is these things actually what actually gives us? This gives us the tuples from loan relation over the loan amount is 10,000 rupees. Here over the 10,000 rupees amount is greater than 10,000 rupees. But we want loan number, not the other attribute values. So first actually we get the relation. This, what is the output of this? Output is the set of tuples or relation, that is information about the loan where loan amount is greater than 10,000 rupees. And if we perform the project operation on that, because this is also one of the relation, outcomes of this part is also one of the relation, that is the input of this project operation, input of this project operation. So from that tuple, from this tuple, which attribute actually we can consider? Only the loan number. Okay, now it display only loan number, only display the loan number, not the other attribute values actually display, only loan number is display here. Okay, which loan number? Those loan amount is greater than 10,000 rupees. Any question from other student, or is it okay? Please pardon me. Any question? Please try to understand. Means if you have any doubt, because so I try to clear you that things, because the query is also the one of the most important things, and as well as the it can uh, uh, some some portion actually of the syllabus is considered as the query, maybe the relational algebra, maybe the relational calculus, and as well as the SQL. There are similar type of query is there, but we can write in some different way. So what is the approach and logic need to be clear. So is it okay, or these are the very simple query, but if you have doubt, then you can clear it. What I believe, if you know the basic things, then you can do any complex things later, or you can solve the complex problem later also. But need to understand first the basic. So these are the very basics, but still, if you have any doubt, please ask. Yes or no? Any question? No. So now, okay. Here, find the name of, what is the query? Find the name of all customer who have a loan, an account, or both from the bank. How you can see here, the borrower relation consists of customer name and loan number. That is, from here actually we can get the information, the customer taking a loan from the bank or not. If customer name is present in this relation, borrower relation, then that customer taking a loan. And to get the idea about the customer who have an account in the bank or not, from which relation need to be consult? Depositor. Okay, need to consult the depositor relationship. So from the borrower relationship, we can get the customer name. Okay, only the customer name. We don't interest in the name of all customer. We only interested on the name of the customer, not the loan number or account number. And from the depositor relation, what we use the project operation, customer name, depositor. That is, this only pick up the customer name column or attribute from the depositor relationship. And similarly here, from the borrower relationship, only consider the customer name, not consider the loan number. Now, how we get this one? What operation need to be perform again? That is, this is one of the relation outcomes, is the one of the relation list of customers. This is also a list of customers who have an account. How we combine this? By using union operation. Am I audible, please?
Yes, audible, sir.
So which operation need to be considered? Because we want list of all customers who have a loan, account, or both. So here need to perform the union operation. Okay. Is it clear?
Yes, sir.
Suppose if we want the information list of customers, just a minute. Suppose the query is say query is find the name of customers who have a loan but not any account in the bank. But not any account in the bank. So what is the query here? Question is clear, na? Find the name of all customer who have a loan but not an account. In the previous here, who have a loan, account, or both. But here actually I want the list of customers who have a loan but not any account in the bank. So what we write? We can find out the list of customers similar to this. List of customer name from borrower list of customers name from depositor. That is, this side is the, this one is the list of customer who have a loan. This is the list of customer who have a account. So in between them, what operation need to be performed to answer this query?
Set difference.
Set difference. Good. That is the need to be performed the set difference operation. This is a set difference. The set difference actually tells us if we perform the set difference in between R minus S, what is the result? The result is the set of tuples where tuples T belongs to R and not belongs to S. Is it the? That is, outcomes is the tuple T. The T belongs to R, that is T belongs to here borrower relation, that is the loan, but not belongs to the depositor, not present in the depositor. So that customer actually our target, the list of customers who have a loan but not an account. Okay. Is it clear for other students? Do you have any query or any question? Now next query is find the name of all customers who have a loan at the NIT Durgapur branch. Please carefully read. Find the name of all the customers who have a loan at the NIT Durgapur branch. So to write this query in relational algebra, first you think which relation need to be consulted. Only one relation is sufficient or more than one relation is there. Then you can think about how we can proceed. To get the desired information, which relation need to be consulted. First you think about and tell me name of that relation. Then you can think about how we can write or how we can get the information by writing the relational algebra operations. Which relation need to be consulted to write this question or to get this answer? Name of all customers who have a loan at NIT Durgapur branch. Please tell me from anyone from you.
Set project and select.
Okay, you can think and you can tell me just.
Set project customer name.
Okay, just a minute. I want actually to see. Okay, sorry. How many students are there? 36 or 35. Why most of the students are absent? Means it's better actually we can take the attendance regularly. Only 50, nearly 50% students are present. So okay, tell me the what are the relation need to be consulted? The relation need to be consulted.
Sir, one will be a loan.
One will be the loan, another will be the borrower. The one relation is not sufficient because in the loan relation you can see loan relation branch name is there but customer name is not there, but we want name of the customer. We want the list of customers, that is the name of the customer. Which customer? Those customer having a loan not only loan taking from the NIT Durgapur branch. So for that, loan relation is not sufficient, need to be consult the borrower relation for the customer name. So now question is actually how these two relation, this one and this one, are relate. That is the this loan number belongs to this particular customer. How we relate? By this loan number attribute.
Roll number.
Because here loan number is the, this loan number is the, in the loan table or loan relation, loan number is the primary, loan number is the, this is the primary key, and here this is the foreign key.
Foreign.
Okay, that basically refer to the, this loan number foreign key actually refer to the primary key here to link up the this corresponding loan is a particular customer. Okay, so now question is actually how we can write that one. So it's better actually we can perform the loan Cartesian product with borrower. That is, this actually gives us a combination of the tuples from both the relation. Okay, and you can see here in both the relation, so what is the outcomes? Outcomes of the is a relation. How many columns are there? 3 columns from loan relation. That is, this is the, this one is here, this one is here, is it? This one is for here. Similarly, this customer name for here and this loan number here. Okay, now you can see this attribute is also loan number and this attribute is also loan number. That is, just a minute, I change the color. That is, this is also a loan number and this is also a loan number. That is, this is identified by a borrower dot loan number and this is identified by a loan dot loan number. Okay, relation dot attribute name. That is the relation name dot attribute name. Okay, if here this is identified as a loan dot loan number. Okay, similarly this is borrower dot loan number. Okay, so now question is from that which row actually we can select where this loan number and this loan number match. Is it na? Because to relate these two tables or corresponding rows, that is that this loan actually taking by this particular customer, this loan number must equal to this. At that time, that row actually we can consider. Is it na? So for that we first write this part. That is, we perform the Cartesian product of this, and from that which row actually we can pick up? We pick up the where borrower loan number and loan dot loan number are match. If this both the loan number are match, that means they can refer both the table. Is it na? Otherwise, the loan number of the one of the customer is associated with the loan number, other customer. So loan number can associate with the correct customer. For that need to be check this condition. So this is the, this can give us a output. No, because here it is not tested branch name. So from that again we can take the, we can select the tuples. Which tuples? Where branch name is NIT Durgapur. You can think like just like a programming. It is also a step-by-step process. You first combine both the relation to get the all combination of tuples. From that you can choose only the tuples where the loan dot loan number equals borrower dot loan number, because to match these two tables, this table and these tables. And from that which row again consider? Some of the row discarded, only consider the row or tuples where branch name is NIT Durgapur. Okay, That is this one actually right now gives us a what? This one actually gives us the same thing. That is the all the columns here it is there, but branch name here in this column, branch name column, it is a NIT D. Okay. Now what we want actually, we want the name of the customer. So now from that actually we can apply the which a person? We apply the project a person. So this provides us a relation or result or set of the tuples. That tuples actually consist what? The loan number, customer name, branch name, amount, where branch name is NIT Durgapur. Now from that we can get the only the customer name. So the result is only the list of customer name only. Which customer name? Those customer having a loan at NIT Durgapur branch. Okay. So any question? So you maybe write this query also this way, not a problem. That is first actually you can cut down the only specify the branch name is the loan, then perform the Cartesian product with that borrower. Then maintain the parity, that is the loan number of the both the relation is match, and then from that you can choose the customer name. Okay. Any question? That is in this case the NIT Durgapur branch actually test actually done later, but here actually first actually test the from the loan table. First select the tuples. Which tuples from the loan table actually select? Tuples those where the branch name is NIT Durgapur. Then such tuples, less number of tuples actually merge with the borrower relation, tuples of the borrower relations, and from that each of the tuples only select the sum of the tuples. Which tuples actually select? Where the loan number is equals to the borrower loan number, because to connect the both the tables, that is the this customer having this particular loan. Do you have any question?
Yes, sir.
Now suppose the next query is find the name of all customers who have a loan at the NIT Durgapur branch but do not have account at any branch of the bank. You try to understand the question first. Find the name of all customer who have a loan, not any branch, loan at NIT Durgapur branch but do not have pay any account of the any branch of the bank. Not only the NIT Durgapur branch, any branch of the bank, that customer does not have any account. We want such list of customers. So for that need to be consult again the two relations. Is it na? Loan and borrower, because in loan relation is not sufficient because here customer name is not there. Customer name is present in the borrower relation. So how connect these two relations? By this loan number attribute. That is this loan number and this loan number is match, means the corresponding customer have that loan and a particular amount. Okay. That is need to be checked here, equality. So how we write this? Similar way again. First we find out you can see the previous query. Here, what is there? This query is find a list of customer who have a loan at NIT Durgapur branch. Who have a loan at NIT Durgapur branch. That is this result is a loan at a NIT Durgapur branch. So for this query, you can think for this query, we first get the list of customers who have a loan at NIT Durgapur branch. Okay, that is list of, that is the logic, list of customers who have a loan at NIT T. Okay. Now what is the need to find next? Now, oh, just a minute. Now, next is we want to find the list of customers who have an account. That is, this is one of the list, and this is another list. This list actually consists a list of customers who have a loan at NIT Durgapur branch, and this one is the list of customers who have an account. List of customers who have an account. So how we get this? Theoretically, please tell me first. I already give some hints. List of customers who have an account at NIT Durgapur branch. List of customers who have a loan and who have an account. So if we perform the set difference operation, if we perform the set operation in between them, then what we get? Please tell me, anyone. If we perform the set difference operation in between these two list of customers, then what we get? We get the desired result or not?
Yes, sir.
We get the desired result, huh? Because this list consists a list of customers who have a loan at NIT Durgapur branch, and this list actually consists a list of customers who have a account. If we perform the set difference, that means what is the result? The result is list of customers who have a loan at NIT Durgapur branch but not account at any branch. So that idea actually we can use here. So this one I already discussed in our previous slide, previous slide. This actually gives us the list of customers. Just a minute. That is, this portion actually gives us the list of customers who have a loan at the NIT Durgapur branch. And how we got the list of customers who have an account? By writing. For that, what we write? Project customer name. For that, which this relation is sufficient. These two relation is not sufficient. Another relation need to be consulted. What is the relation? Depositor. That is, here we write the customer name from depositor. Okay. So this actually gives us this list. That is, for that we need to consult the depositor relationship. I think it's difficult to see, na? At least this is right now visible. That is, this one is this one. That is, this portion actually gives us a, just a minute. This portion actually gives us this list. That is, list of customers who have a account at any branch. Is it? So if we perform here, in between them, set difference operation. This is the set difference. Okay. Is it okay or you have problem?
Sir, can you explain again?
Okay. From beginning.
No, sir. From when you started the equation.
Okay, just a minute. Means what is our query? Query is find the name of all customers who have a loan at NIT Durgapur branch. Just 1 minute. That is query is find the name of the customer who have a loan at the NIT Durgapur branch but not any account at any branch of the list. So how we get idea actually, I want to find out the list of customers who have a loan at NIT D. Okay, NIT D branch. Is it clear? This is the one list actually we want to find out. And also
Yes.
we want to find out the another list. We want to find out the another list. That is the list of customers who have an account at any branch. I want to find out list of customers who have an account. Okay, that is two list is there. This is the one of the list. This list is the this one, and there is another list. This list is the this one. Okay, so this one actually consists what? This one consists the list of customer who have a loan at NIT Durgapur branch, and these are the list of customer who have an account. If we perform the set difference operation in between them, these two lists, set difference between these two lists, what we get? Set difference means the tuple present here, not present here. It is present here, but not present here.
Yes, sir. In the first one, not in the second.
Which one?
In the first one, but not in the second one.
Yeah, that is the not in the second one. So it is
Yes.
present in the first one means what? The customer having a loan, it is present in this list. So customer having a loan at NIT Durgapur, but not present here means that customer does not have any account. That is our requirement. That is our
Yes.
query, na? That is our question or target. Okay, this is the idea. So to implement this idea, which table need to be consulted? To get the list of customer who have an account at NIT Durgapur branch, for that need to be consult the which one? Loan table, loan relation, and as well as the borrower relation.
Borrower.
Both the relation is need to be. Now how we write? Just simply we can this one we write in our previous example also. That is that this actually gives us a list of customer who have a loan at NIT Durgapur branch. That is this portion. That is this part of the query. This part of the query gives us this list. Okay. Now, how we got this list? To get this list, what we write? List of customers who have an account. To get this query or to get this result, which relation need to be consulted? Loan and borrower is not need to be consulted here because this is related to account. So need to be consulted the what? Need to be consulted the depositor. Need to be consulted the depositor relationship. Okay. Need to be consulted this depositor relationship. Okay. So what we write? Project customer name. We write the project customer name depositor. Okay. So this actually gives us a this list. That is the list of customers who have an account at any branch. And this one we perform the now set
Between
difference
these two.
operation.
Yes, sir.
Operation, that is, we can perform the here set difference operation. This is the set difference. Okay. Okay. So finally, if we perform the set difference operation, then we get the list of customer who have a loan at NIT Durgapur branch, but not any account at
Present.
any branch of the bank. Okay.
And that, sir, any account, any branch comes
So
from customer
okay,
name
it's
depositor.
better. Customer name in depositor.
Yes.
If the
From
branch
that,
name is
yes, sir.
if the query is changed, say if the if say this question is find the name of all customer who have a loan at NIT Durgapur branch but not an account at NIT Durgapur branch, then at that time need to be consult. Similar way need to be write
Yes, yes,
the
sir. Customer
depositor with
name, branch
account.
name, NIT.
Similar the similar way need to be write. Okay, they are actually in place of borrower we need to write the depositor and here account. The same thing, because at that time this set is the list of customer those have a account at NIT Durgapur branch. Okay, so that time not this one need to be write the these things for the depositor and as well as the account relation need to be consult the account relation also. Okay, because in the account relation branch name is there, similar to the loan here branch name is there. So in depositor relation there is a no branch name is there. Okay, any other question?
No, sir.
Okay, one more slide, just I can complete it. Suppose the find the largest account balance. Find the largest account balance. Now we rename, first things actually we rename the, how we find the largest account balance. The balance is stored in where? In the account relation. Okay, but how we get this? Because how we compare balance with the next balance or like that.
We
So
sort.
for that we use the rename. That is the renaming operation. That is we rename account is renamed with D. That is from this part. To forget about the remaining part. From this part actually what we get? This Cartesian product. You can see that this one row D account. What is the meaning of that? D is also a name of the relation that contain the same account number, balance, branch name. Is it na? 3 attribute. Is it? So when we perform this Cartesian product contain how many columns? One column for account, this branch, second column, and this one for this. Okay, what we write here? Account dot account number, account dot branch name. This is account dot balance. Okay, and for here, this for this attribute, and for this attribute. What is this? This is a account number. This one is the account number. This one is the branch name. This one is the balance. Okay. So this one you can see here. This one is also a account number, and this one is also a balance. But what we write for this balance? This balance is actually D dot balance. Sorry. Just a minute. That is this one is the D dot balance. Okay. And this one is the what? This one is the account dot balance. Is it clear now? This one is the account number, account dot branch name, account dot balance. This is d dot account number, d dot branch name, d dot balance. Up to that is clear, na? So
Yes, sir.
this Cartesian products gives us the all combination of the same tuples. So now from that we compare or select the tuples. Which tuples? That is the account dot balance, right, less than d dot balance. That is this portion. That is this portion.
Class.
This portion gives us a list of balance list of all balance except maximum or largest, except the maximum or largest balance. Is it clear? Because by that comparison it eliminates the largest one. It consists of all the balance. So here again we want to use the set difference. That is, we want here one list actually consists a list of all the balance, and another list consists a list of all the balance except maximum one. If we perform the set difference, then what we got? The largest balance. Okay. So how we got the list of all balance? By this. That is, this actually gives us a list of all balance. That is list of all balance and set difference of list of all balance except the maximum one. That means what is the result? Maximum balance or largest balance. So we perform the sorry, this one is the mistake is there. Just a minute. Here little bit told you little bit mistake in the sense this actually gives us a list of not only the balance, it also gives us a all the things, list of this whole tuple. That is whole tuple actually it gives. From that actually this one actually gives the list of only the balance. Okay, and this part actually gives us a list of all balance. So if we perform the set difference, this is the set difference, then we get the largest balance. So okay, do you have any question?
No, sir.
So in our next class we discuss the next additional or advanced operation of the relational algebra. Just a minute.